Okay, welcome back and good afternoon to you. This is the second of the Sustainable Transport Maritime sessions. We've got many speakers for you today in the afternoon, really following on from what we were covering in this morning's session. This morning's session we were looking at all the different fuel options for decarbonising maritime, and we're here this afternoon to hear further about various fuels, including bio-LNG, biomethanol, synthetic versions of each of those. We've got, as you can see, several speakers on the panel. We're going to run through probably about half of those before we just take a short break. Otherwise, we might all be falling asleep when we get to person number 7. So without further ado, just introduce myself if you didn't catch my presentation this morning. My name is Tim Scarborough. I work for Ricardo, which is a global environmental and engineering consultancy. But the stars of today are the speakers. So let me introduce your first speaker, Sergio RIOS, who is an experienced R&D process engineer, PhD in chemical, environmental and process engineering, over 20 years of experience in biofuel production, biomass valorization, and circular economy practices. Sergio, over to you.
So, can you hear me? Well, thank you very much, Tim. Thanks for the invitation. As said, my name is Sergio Rios. I'm working at XFuel with the headquarters in Palma de Mallorca in Spain. And I will present the technologies we developed so far. The title of my presentation is Keeping the Oil Underground with Affordable and Low Carbon Dropping Fuel for Transport Today. I think there is no explanation on the title, but yeah, we are platform technology developers. So our leitmotif is to keep the fossil in the ground and work with the things that are available above the ground. So the presentation is pretty academic for me. I'm a PhD, I'm a scientist as well. So I organized the presentation in 3 main parts. First, the challenges we are addressing with our technologies, and I think my colleagues as well. So later on, after this contextualization, I will move forward with our technology overview. We have 2 technologies in the pipeline. One so-called chemical liquid refining, CLEAR, and the second one is the mechanical carbon conversion, so-called MEC. After all, I will do like a kind of summary with some of the competitive advantages and where we are so far with our technologies. So, about problem, with problems are always coming some alternatives to find a way to be better, let's say. So, as the EAI have confirmed, transportation is responsible of more than 20% of the global emissions so far, and it's rely a lot on fossil. Especially the transportation which is rely on fossil fuels is mostly shipping and aviation. It's something for the energy density needed for this type of energy are pretty high and cannot be covered by the electric so far. Sure, there will be much more alternatives, but so far seems that this oil consumption and shipping and aviation is projected to even increase 80% by 2050 with the current policies, and can be reduced only 4% if we meet all the announcement pledge and fully and on time. So it's a pretty challenge that we have. We are working on those challenges. We accept that challenge. And we start developing some technologies 10 years ago. One of them is ready to take off, the so-called chemical liquid refining, which is a one-step refining to valorize waste hydrocarbons liquids into ultra-clean dropping fuels. As I said, it's about to be commercial. We are expecting to have our first commercial plant by the end of the year or early next year in Palma de Mallorca. And it's been already validated with 85% of greenhouse gas saving by SGS, which is a well-known company working on this type of validation. Our second technology, it's MEC, it's called MEC, it's a mechanical carbon conversion, which use the same type of oil waste, but also adding some biomass into the equation. So in that sense, we might be able to even reduce the greenhouse gas saving above 140%. This is something work in progress. We are expecting the first plant by 2026, but needs to define the location yet. So we are able to use a wide range of biogenic and non-biogenic wastes across our technologies. As said, lignocellulosic biomass waste is the most relevant for our MEC, actually. So it can be any lignocellulosic waste from agricultural residues, construction, manufacturing, or forestry residues. I need to be blended in the MEC with industrial waste like lubricants, shipping waste, for instance, the Marpol Annex 1, or any other industrial oil or petroleum waste, and even some non-edible oil which we are working, for instance, cashew nut shell liquid, which are showing very promising results with our technologies. To be highlighted, we are certified by the ISCC, by the product itself. Our marine fuel is being certified, and also the different inlets we are using in our process. Now I will go a little deeper in our clear technology, and I will show you like kind of a business case we are working so far by using this Marpol Annex 1, which is pretty much available from the shipping industry. It's about 3% of the bunker they use. So if you make some calculation, they might be available from 5 to 10 million tons a year of this type of waste. It's a really hazardous waste, so it's expensive to treat as well. So we are giving second life to this waste. Of course, we are just scratching the surface because we are talking about a market of, I don't know, million tons size. So it's a pretty big one. So we need to, find other solutions as well. The technology itself is it's a patented technology. The process itself is patented, and also the heart of the process, which is a turbine, which you blend it in that or mix in that turbine the impure hydrocarbons, which can be the Marpol Annex 1, but also there are some other waste material that can be blended there with a chemical reactant. I can not mention too much about it, but it works pretty all right. It's a high availability of this type of reactant. We don't use external hydrogen or any other sort of additive more than this reactant. And the conditions are pretty mild, so the capex are also low enough. And with this, with this process, we get a very clean transport fuel as MGO. Also, we can have it raw diesel, and we are working toward also aviation standards. We are already, so far the first idea is to get the shipping industry circular, so our first approach will be always marine. So a glance of how it looks, the waste before and after our process. You see that somehow the technology cracks and purify the stream, so reducing the boiling points, of course. And with those different boiling points, we might be able to get this MGO with the ISO 8217 specification, a fraction also from road diesel, the EN 590, and we are working toward the SAF as well in the lower boiling point. A glance of how it looks, an analysis of our fuel. In this case, we work with the Greenport Hamburg tank sludge. So as you can see, in general, they met all the parameters, all the standards regarding the ISO 8217 for marine fuel. And well, to highlight that we can go lower in the sulfur content if necessary, let's say. Our second technology is the MEC, the mechanical carbon conversion. Is expected to be taken off by 2026, the first commercial plant. We are working with our investors, and they are pretty excited about it. So the technology itself, it's a patented technology as well. The heart is it's a turbine, a reactor turbine, which works 100% by friction and cavitation. So all the thermal transfer is bathed by waste oil, and then we blend it with a different type of lignocellulosic biomass to get out at the end of the day, at the end of the process, the sustainable dropping fuel, which also get 95 to 145% of greenhouse gas saving. Other than the fuel, we get biochar and wood vinegar, as you must have in most of the thermal conversion of biomass. And of course, we are valorizing the carbon removal credits. This is a glance of how it looks, an analysis of our fuel. As you see, all between the standards as well. So this is a work we perform with Boral in Australia using eucalyptus in our reaction, and then we blended with low sulfur MGO for the analysis, and check the in-engine test and blending test, and so far and so. So our fuels in general, they comply with existing fuel standards and have been extensively tested and certified. The marine fuel is the one that is higher in our needs. So it's been already pretty much analyzed, blending studies and in-engine tests. We're expecting once we have our full commercial plant to really make 20 tons to make a ship move for an hour at least. So we are also exploring the road transportation fuel with the EN 590, which were also analyzed and blended studies were performed successfully. And then we are working with the University of Sheffield and the German Aerospace Agency, DLR, working on the aviation fuel as well. As said, we don't produce just fuel, but also biochar, which we are exploring different alternatives where to use it to improve our business case. So far, we were trying in soil amendment and concrete, replacing some concrete, replacing some sand as well. We found a really nice effect of our biochar into the concrete. However, this is a work in progress. We have different partners where we are exploring this type of byproduct valorization. Boral, Fraunhofer Institute, for instance, some universities, so on and so forth. So as to sum up a little bit, the competitive advantages of our fuel. I plot this based in the McKinsey report. It is for a SAF, but I kind of extrapolate for the marine fuel. So you can see there where the fossil are in price and the savings. So no saving at all, and the price is below 900 euros per ton. So our clear technology in the bottom right, it's already at fossil price. However, as it was validated with 85% greenhouse gas saving. The future, it's MEC, our other technology, which use also lignocellulosic biomass, which is we are working on the business case because profitability is important. So we are having very nice results, certified greenhouse gas saving, more than 140% of greenhouse gas saving. And if you see compare with other alternative technologies as well, we are competitive enough with them, but I insist that we are not competing each other, but we are competing against the fossil and time as well, of course. So where we are so far, we have our operation plan in the Palma de Mallorca. We have both technologies in pilot scale. In the case of the clear, we are working at the batch. This is something we are about to automatize and make it continuous. And then we are expecting by the end of the year, early next year, to have our first commercial plant, which is the C2. We already have the feed, the front-end engineering design. We are working on the permitting for the location in Palma de Mallorca, which is always difficult to place this kind of technology in an island. So we will be able to produce about 14,000 tons of MGO per annum. And our future, we see our plants all over the ports, over the globe as well. So the max, we are planning this modular type of construction, is the C10 plant, which means 5 times the C2. And this is work in progress as well. Regarding the MEC technology, like the one that used biomass as well. So we have our demo plant in Palma de Mallorca, able to produce about 1,000 tons of MGO per year. This is what we are working on de-risking so far, working with collaborators to prove that the MGO is good enough and making the blending test and so on to move forward with the M4 plant, which is the smallest commercial plant that can be profitable so far. So to summarize, we produce liquid fuel replacement, 100% blendable and drop-in, so there is no need of changing any infrastructure, engine or anything. So that's a plus, and will also short the time to move forward to something more sustainable. Sustainability also it's our core business. We already proved 85 to 140% of greenhouse gas saving. It's scalable. The waste oil probably cannot replace 100% of the needs of the shipping industry. However, if you combine it with the biomass, I guess it is something it can be done. To also highlight the low cost, we are talking about very competitive product cost at the same price of fossil with a clear, and it's a little bit higher for the MEC. However, we are working to reduce these prices. So if you compare with other alternatives, the capex investment can be up to 5 times lower due to the process conditions. So thank you very much, and looking forward for questions.
Thank you very much, Sergio. Very interesting presentation. I'm looking for questions from the floor. Are there any questions from the floor? Whilst you're thinking of questions, Sergio, I'll ask you one myself. So this looks very promising technology in that you've articulated its low cost. So my question is, why are they not buying it all up already? And how quickly can you scale? And when you scale, do those prices remain?
That's a very good question. We are we started like 10 years ago with the technology. I joined the company a year ago. Somehow we have our first round of investment about a year ago. So we are expecting, well, to have a second round of investment by February, and then we hope to have because for instance that's why we did also partitionate the development of the Clear first to get some money and then get some also trust from several investors and move forward with which is profitable. We need our capex are 9.5 million for the Clear 2, so we are expecting to have it there by the end of the year, already built up. We did already the front-end engineering. We are working with the permits.
Great, sounds very promising. Any questions from the floor? Well, you can store up your questions, and we'll take some more questions at the end. So thank you very much, Sergio.
Thank you.
So our next speaker for this afternoon is Dennis Rasmussen from European Energy. He is Chief Process Specialist at European Energy in Denmark, previously a project manager at Strandbullen for construction of a 3 megawatt electrolysis hydrogen plant, and before that spent 27 years at Haldor Topsoe as Director for New Technology Engineering at the department there. So welcome, Dennis.
Thank you. Okay, I'll give you a light presentation this afternoon, not too many numbers, and give you an impression of what we do in European Energy in realizing power to X and green renewable fuels. So you will see some pictures and videos, which I guess is also okay. And I will tell you about our ongoing projects. But first, a few words about European Energy. We are a leading renewable energy company with a global presence, mostly in Europe, with main office in Denmark. And we are working in 4 different areas: solar power, onshore wind, offshore wind, and power to X, or renewable fuels, if you like. And that gives us a good wide portfolio to work with. The company started in 2004, and since then we have installed more than 3 gigawatt of renewable power, solar and wind. Right now we have 1 gigawatt under construction, but it goes very fast these days. I think the slide is a bit old. As late as yesterday in the hotel, I read the news that we signed a PPA agreement in Australia for 1.3 gigawatt. So it's going very fast these days. We have a development pipeline of 60 gigawatts now. So yeah, we are quite busy. We have our own project development with a lot of competences in-house for screening of sites, planning and permitting, funding, grid connections, PPA agreements, and a whole lot. It's a big task. I'm an engineer, and I thought the whole was about engineering and plant design, but the permitting is maybe the biggest challenge. But that we are very good at, and then we have our own technologies for hydrogen, methanol, and CO2 capture, and CO2 cleaning as well. We have our own in-house EPC organization that presently are working on the construction of our first PTX plants that I will show you about a little bit more about later. And of course, for many years we have been operating and maintaining our solar and windmills, and now we are expanding our O&M department to handle our chemical plants as well. Okay, a bit about some of our ongoing projects. We are working on construction of a hydrogen facility in the west of Denmark, near Esbjerg. We have 3 windmills there already, producing power, and then this power will be supplied to this hydrogen facility, and we will make grid services and produce hydrogen for trailers and district heating. The 12 megawatt will be 3 different types of electrolyzers, so it's you can call it a testing site to try out different technologies and get some experience with hydrogen production and grid services. This is pictures from the site. The actual photo is from October last year, I think, so it's maybe a little bit old, but things are progressing very well on site, and we will expect commissioning here around summer, producing the first hydrogen. But our biggest project and maybe most interesting here is our e-methanol plant in Kassø, in south of Denmark. We have already the 300 megawatt solar park in that area that is in operation right now, and we are now constructing a e-methanol plant to produce 42,000 tons of methanol per year, based on 52 megawatt of electrolysis. And when it's commissioned later this year, it will in fact be the biggest e-methanol plant in the world in operation. We have already offtake agreements in place, of course, with some good partners like Maersk, Lego, Novo Nordisk, and Circle K. So that is also an important thing. Yeah, and now I will stay quiet for a little while and show this video, which give you a guided tour in our methanol facility, so you can see how it actually looks like. Can you start it? This is the solar park we already have. And there you have the methanol facility. The video will explain itself. So. We have 3 electrolyzer buildings, 3 arrays, each 17 megawatt. And hydrogen goes to compressor building, where we have 5 reciprocating compressors, bringing pressure up to 35 bar something. The blue line is the evaporated CO2 from the storage, and then the combined gases goes to the synthesis sections. We have 2 parallel trains. So we have, synthesis section where the CO2 and hydrogen are reacted into methanol and water, you can say, and then the water is removed into distillation, and the methanol product goes into storage. The storage is kept underground for fire reasons, and then the methanol is loaded on trucks for and sent to our off-takers. And last, we collect the district heating from electrolysis and also from the methanol reaction. Good. Yeah. I think that was a nice video, so I thought I would show that to you. And but okay, these days you probably see many renderings and animations and stuff like that. So actually, I will now show you a real life short video of the same site, actually, but taken with a drone. I think in October, November last year. Can you try start it? Oh, maybe there it is. That one. You can see the solar park again on the right side, and I'm sure you can recognize the site from the animation. This is before the winter started in Denmark, so but it's still quite wet. The construction is going well, and we will have our commercial operation end of this year, and that will be a great success, I think, for everybody. So. Yeah, I think that's it, and I just thought it was nice to see the comparison between the animation and the video. So this is how things become real, and that's the main projects that we are have under construction right now. But we have a long pipeline of PTX projects and are looking into projects all around the world. We are right now screening working on the projects in 10 different countries, not only Denmark, but also Sweden, Lithuania, Spain, US, Australia, and Brazil. We have our own in-house screening tool with geographic information system and data. And we are constantly screening for the most attractive sites, considering cost of energy, logistics, infrastructure, access to CO2, biogenic CO2, all these things that are necessary to make it happen. In Denmark, we are right now looking at 3 different projects, Nakskov, Padborg, and there's one more. The project that is being constructed right now is Kassø, the blue dot. And Denmark has several advantages when it comes to PTX, because we have a lot of renewable energy and also quite a lot of biogas. So that's important factors, and the sites that we have here are all close to the high voltage transmission line coming up from Germany up through Denmark. It's the red line you see over there, and it will also be next to the future hydrogen backbone, the pipeline for hydrogen distribution. So that's all good strategic arguments for these locations. We are quite busy, and maybe you know, in last year Danish government carried out a hydrogen tender, and European Energy, we quoted for 3 projects, and I think as a recognition to what we are doing, we actually won all 3 projects, which is great. I mean, all the top people, they were happy, and all us who has to do the work, we were not so happy. We all happy, but we are going to be quite busy. The 3 projects are the last phases of the hydrogen facility, which expanding capacity from right now 3 megawatt to 12 megawatt. And also we will increase electrolysis capacity in our methanol plant. So we will install additional electrolysis and a hydrogen buffer so that we can optimize according to the power production and power prices. But last and maybe most important, that's our next e-methanol plant that we are working on in Padborg, which is going to be 160 megawatt of electrolysis, not 150, but 160. And the total subsidy here was more than 1 billion Danish kroner. So that's good, but it also comes with a lot of commitment. We have a strong commitment to reach COD before the end of 2027, and we will be penalized if we don't make it. So we are motivated, and we move ahead. Last, just a few words about this project. As I said, it's 100,000 tons of methanol per year. We can actually produce more. It depends on how much they want to run the plant. I think design capacity is 360 metric tons per day. So then you can do the math. But it's certainly more than 100,000 tons. And we have already secured the land down south in Denmark, near to the German border. And we are working with the local municipality about planning of the site, water supplies, water drainage, disposal. And that is really the big deal here. The basic design or pre-feed or whatever you call it is also on its way. We are quite advanced for that, and we expect to start feed in March, April, and then make FID end of this year. As I said, we already have subsidy support for this project, and yeah, so we are moving ahead. So that was it. Thank you.
Thank you very much, Dennis. Very interesting and great to see the scale of these plants rapidly growing. Are there any questions for Dennis from the audience?
It's nice to see power to liquid project. So I would ask diplomatic question. What is the minimum offtake price that can be accepted for the e-methanol? So to not ask you directly what's your offtake price, what is the minimum offtake price you see it in the market accepted?
Oh, you're not the first to ask that question. Many
Everybody will know.
business partners are asking that question, and our CEO is always trying to get around that. But you have to work it backwards from, what's it worth. It's not about, production price and then adding overhead. It's about what saving and how much the shipping companies will pay for it.
Yeah, this is the question, because the production cost of the e-methanol is almost like well known in the 1,150. So is the shipping company willing to pay 1,300, 1,200 for the e-methanol?
It will certainly be in that range.
Okay, great.
Yeah.
I got my answer.
Very good. Any other questions?
Yes. So thank you for your presentation. I have two questions. The first one is on the e-methanol plant, what is the CO2 source? Because is it biogenic or not?
Yeah, it's biogenic CO2 from nearby biogas plants. There are two biogas plants quite near the methanol facility, so that's where we get our CO2 from. It has to be short because it's quite tight on the carbon intensity. I think we need to keep it below 5 milligrams, or is it 5 grams per megajoule? But we cannot allow the trucks to drive too far.
Okay, so you make the link with my second question, which is the fact that you have acquired ammonia gas 2 years ago, and my question was more on the strategic orientation. Do you want to keep ammonia gas providing a biogas upgrading unit, or focusing on the CCS business?
Ammonia gas is purchased by European Energy, but it's still a separate entity. And they have their business, but yeah, I think we took over that company to create some synergy, but they are not involved in this at this stage, but hopefully in a later stage. I mean, we are spending a lot of energy in sourcing CO2, and that is one of the big challenges, and that's one of the possibilities that we actually go into biogas ourselves, or gasification, or whatever we need to produce the CO2 that we need.
Okay, thank you.
Yeah.
So thank you very much, Dennis. Oh, we've got another question. Sorry. Thank you, Laurent. Another question at the back.
Hi, so my question is on the plant that you just showed us. You had the solar park right next to the plant. Is it the only type of electric supply that you have for electrolyzers? Or is it also grid connected so you can operate at night?
We are also on the grid, and
Okay.
and the funny part is that we will often take power from the grid. So when the prices are high, we will sell the power and turn down the methanol plant, and when the price is low, then we take the power behind the meter and produce maximum methanol.
And then do you track emissions from the electricity that you buy from the grid to make sure it's low carbon?
Yeah.
Okay. And how do you do it, or is there
No,
any
but it's total. First of all, I think there's a high percentage of green
Renewable.
power in Denmark. That's also helped. But when you add it all up, there's a system to record how much we take in, and we don't take more power from the grid than we are allowed to in order to call it a green methanol.
Okay.
Yeah.
Thank you very much.
Great. And final call for questions. Laurent, yeah.
If I understand well, the electrolyzer will do some kind of load charge, which is quite ambitious on your part. What I see is, what I hear everywhere is that electrolyzers are extremely difficult to stabilize, to work. To have them working properly is already a challenge when they're on base load. And I see that you take very bold engagement for quite significant electrolyzer that will run following the load charge in just 2 years or 3 years.
Yeah, right. You're right. As I mean, the electrolyzer is a big challenge. I'm fully engaged on deciding on technology and suppliers for our next plant, which will be 160 megawatt. But no suppliers can deliver one plant of this size. So it will always have multiple units. So you can shut down units when you have low demand. And well, this first plant is also done with PEM, and PEM has a pretty good turn down, and it's very fast reacting. And then we have built in buffers in the process design, so that the downstream plant can accommodate the fast changes. So it should work.
Okay, thank you very much, Dennis. I think we should move on to our next speaker, so thank you for that. Our next speaker is Steve ESAU from SEA-LNG. Welcome, Steve, to the platform. Steve is the Chief Operating Officer at SEA-LNG, and before that was Head of Energy at Zinteo. Began his career as a geophysicist in BP, various roles across business development, strategy analysis across the company's gas, power and renewables and energy trading businesses. Welcome, Steve. Over to you.
Thanks, and thanks to Bio360 for the opportunity to speak today. Today I'm going to go up to not just a helicopter, but maybe a satellite view of the shipping industry. So what I'm going to do, well, first of all, a few words about SEA-LNG. SEA-LNG is a global industry advocacy organization. Our focus is on increasing the understanding of the environmental and commercial benefits of LNG and the pathway it offers through bio-LNG and synthetic LNG to decarbonization of maritime. So today I'm just going to talk about the challenges of decarbonizing the shipping industry, the status of the LNG fuel fleet, which is essentially the asset base for these green gases that are increasingly being produced, and the broader pathway to decarbonization. So I think one of the things, if it hasn't been labored enough, is that we need to realize is that shipping is really, it's one of the most difficult sectors to decarbonize. It's sort of the hardest to abate of the hard to abate sectors. It's likely in future it's not going to be a one-size-fits-all solution. There's not going to be one fueling solution. For short sea shipping, where you have regular port calls, you may see the adoption of hydrogen and battery systems. But for deep sea shipping, where the ships commonly don't fuel or run for about 6 weeks or so, 1 to 2 months between refueling, it's likely that fuels with a much higher energy density are going to predominate. And that means likely LNG and its derivatives, potentially methanol, potentially ammonia. So there are a number of prerequisites for renewable and low carbon fuels. It's not simply removing the carbon atom. It's also a matter of removing the carbon atom at the cheapest possible commodity cost. There are some characteristics these fuels need to have. Firstly, they need to have as higher energy density as possible. If you're taking fuel to sea, you're not refueling for between 1 and 2 months. You're going to be carrying a lot of fuel. More space for fuel is less space for cargo, so there's a big impact on economics. Any propulsion system using future fuels needs to be utterly reliable. A ship really can't afford to break down at sea. There's no AA rescue service available. And any fuel needs to be completely safe, and that's for the crew, for passengers if there are any, and also for the port communities. And this is one of the experiences that we've seen with LNG is acceptance of these new fuels, particularly in port communities, and increasingly now when we're talking about ammonia for crew is a massive, massive issue. Now, by all these criteria, LNG is advantaged. You see the traffic light table there at the moment. And it's not to say other fuels may not be able to catch up. They very likely will, and we're seeing a lot of technology developments. But one of the things that we need to emphasize is that decarbonization for shipping, and just as with other sectors, needs to happen at unprecedented speed for the industry. So what is the technological and regulatory status of the various marine fuels? Well, LNG fuel and methanol, this is data from DNV, one of the major class societies, are ready for adoption now. For the other fuels, really looking at ammonia and hydrogen and then potentially onboard CCS, which can apply to a variety of fuels. The technologies and regulations are really not going to be anywhere near ready until the end of this decade. Another issue when we're talking about the decarbonization debate is to have some clarity. I think one of the big things to emphasize is all fuels share the same decarbonization pathway. So LNG today is fossil. Methanol today is predominantly fossil, as is ammonia, as is hydrogen. They're all moving from a fossil state to an electrofuel state. And the economics are really driven by the costs of renewable electricity and hydrogen electrolysis. The hydrogen is the feedstock and will account for 70 to 80% of the costs of producing these electrofuels. The one thing that LNG has in its advantage in that at the moment, in its fossil state, it offers immediate greenhouse gas reductions. The other fuels, it's pointless to use the fossil versions because those versions actually have far higher emissions than the thing that they're looking to replace. So what's the status of LNG as a marine fuel? Well, we've seen a dramatic acceleration over the last 2 to 3 years in the uptake of LNG as a marine fuel. And by about 2027, there should be about 1,000 LNG-fueled vessels in operation, and this excludes the LNG carrier fleet. That sounds a lot, and you can see the curve there is heading towards being asymptotic. But the thing to emphasize is that's 1,000 vessels in 2027. The size of the global shipping fleet is 66,000 vessels. So LNG is traveling on a good trajectory, and maybe we'll see other fuels also following that, but there's a lot of investment that's going to need to be done. In terms of infrastructure, LNG bunkers are available at about 200 ports worldwide. And here LNG has the advantage that there's a massive global infrastructure of LNG production and liquefaction. Many of the regas facilities with massive storage tanks are situated near, in or near major trading ports where ships would normally bunker. So now let's look at the decarbonization pathway that LNG offers. So as I've mentioned, it starts today with an immediate greenhouse gas reductions of up to about 23%. It continues with bio-LNG and synthetic LNG. These are very simple drop-in fuels. They're simply the methane molecule. You're blending essentially methane with fossil methane with a bio or synthetic molecule. There are no blending issues. It's low risk and incremental, the pathway. And again, importantly, it uses the existing infrastructure, the bunkering facilities, and the growing LNG fleet. So there are no stranded assets. So now let's look at bio-LNG in a little more detail. I think one of the things to emphasize, and we commissioned a study a number of years ago from CE Delft, and the question we asked them, so how much potential bio-LNG sustainable produced from sustainable biomass is there? And I think to our surprise, and this chart will show it, is that bio-LNG, or perhaps more correctly, biomethane produced from sustainable biomass, has a potential to be an energy resource which is multiples of shipping's total energy demand. And I think this analysis is again backed up by recent analysis by the IEA. So it's a potentially a very, very big and significant resource. Clearly, it's not only shipping that's going to be drawing on that resource. So we asked the NTU in Singapore to look at what of that potential bio-LNG or biomethane resource might be available to shipping. And once you take into account demand from other sectors. And again, I think the ballpark numbers are actually very interesting. So I think in 2030, biomethane could supply up to about 3% of shipping's total energy demand. By 2050, about 16%. And if used as a drop-in fuel, it could fuel a greater number of ships. Now again, this is a desktop exercise, but it does again show give an indication of the realistic potential of bio-LNG as a solution for shipping. So we've looked at availability, promising. We talked a little about costs. I'm just flash this chart up in front of you. These aren't our costs. These are costs taken from the Mercer McKinney Moller Center for zero carbon shipping. What we can see is essentially to decarbonize, the basic message is that shipping is going to move from using the cheapest fuel, the bottom of the barrel, with a cost of around about $10 per gigajoule, to a world where they're going to have to pay significantly more for their fuel. And you're looking in terms of electrofuels at a costs currently between 5 to 7 times higher than current fuel prices. Biofuels, and perhaps fuels like blue ammonia may be significantly cheaper, and it's likely they'll have a greater role to play in the short to medium term. Of those alternative fuels, again, the data from McKinney shows that biomethane or bio-LNG is currently the cheapest alternative fuel. Bio-LNG looks like it's probably going to be amongst the cheapest of all the alternative marine fuels available. So what's the situation today? We asked our members, where would you be prepared, or where can you supply bio-LNG as a marine fuel commercially? And their answer was roughly around about 70 locations worldwide, notwithstanding regulations that need to be further developed in certain cases, but physically they're able to deliver bio-LNG in about 70 different bunkering locations worldwide. So what of the long-term future? Clearly the pathway to decarbonisation, bio-LNG can take you part of the way there. Bio-derived fuels are going to be a limited resource. Ultimately, if we're looking at, again, the future in maritime, and I guess that's the same in aviation, we're going to need to be looking at electrofuels. It's a potentially unlimited resource. We don't see these as having a significant future until about 2030 onwards. I think, but what we are seeing are the announcements of numbers of projects now for e-methane or e-LNG production. We see certain governments recognizing, for example, Japan, which has a high dependency on gas, looking to actually decarbonize the gas in their grid system. We saw the announcement of an offtake agreement with Gasum from Nordren, the renewable energy supplier in the Baltics, for 2026. So again, e-LNG there would be available to shipping in Europe in round about that time frame. So, in summary, our view is that bio-LNG and e-LNG, while not the silver bullet, do represent a robust pathway to zero emissions for shipping. The technologies are mature for production and use on board ships. There's a rapidly growing asset base of LNG fuel vessels which can use bio-LNG and e-LNG as a drop-in fuel. There is existing and growing infrastructure which can be leveraged. There's a significant potential global supply potential of bio-LNG, which I'm imagining one of the speakers to follow will talk about. Clearly, in terms of cost competitiveness, bio-LNG is amongst the cheapest of the future marine fuels. It's commercially available now, and adoption of bio-LNG helps pave the pathway for the full decarbonisation of shipping through e-LNG. I'll leave it there, and happy to take any questions.
So thank you very much, Steve. Very interesting presentation to hear on the development for LNG fuel vessels to move through bio and e-LNG. I'm looking to the audience for questions for Steve. I can see one over there, please.
Thank you for the good presentation. And one very basic question. So we are all hoping that bio-LNG will come in force and will be available for all the consumers. Unfortunately, we already need to serve the heavy-duty vehicles market in Europe, which is a huge demand, and there is a clear shortage of product. So when you add to this the maritime industry, it becomes very, very huge. And I'm wondering how you can figure out the supply of let's say, a very nice product to a very big demand, and how can we satisfy this demand?
Yeah, I mean it's a very good question. I think on the supply side, regulation's going to have a role to play. I haven't done much in the murky world of biomethane supply, but one thing from the demand side, I think what we need to see is a real clear market signals hitting the supply side. So what I mean more concretely about that is the adoption of the member states of mass balancing. So biomethane, bio-LNG can be lifted at the LNG terminals, and essentially the gas injected into the European grid system. Very similar to the way, and obviously, in which the electricity market decarbonized. So you have that disaggregated production resource injecting into the existing infrastructure and being able to be taken off. So we see if that mass balancing is realized within the member states, we'll see that as a very powerful demand signal for supply. Because I think the point is there is, you look at numbers from the EBA, a massive potential for biomethane supply, a sustainable biomethane supply in Europe.
Thank you, Claire.
You showed the price of the bio-LNG is like 25 euro per gigajoule.
Yep.
So at the current situation, this price is not attractive at all. It is exactly equal to 85 euro per megawatt thermal of biomethane, which is the current price now in Spain, at least, not in Germany. So you need to be at least in the 37 euro per gigawatt joule for the bio-LNG to be attractive business. Otherwise, it will not be economy, because you need to put more power to compress the biomethane to be LNG.
Yeah, I mean, I think one thing that chart didn't show prices, it showed costs. We wouldn't talk about prices, so we're looking at production costs.
If the production cost, that means the price should be much higher.
Clearly. I mean, no one's going to buy in the shipping industry. They're used to buying the lowest cost fuel. No one's going to buy bio-LNG unless there's a demand from their customers. And you do see that through the voluntary markets, some, not much. It has to be driven by regulation. So, and then you're looking at, so, okay, I need to comply. What's my lowest cost of compliance? Yeah.
Thank you. Any further questions from the audience? Steve, I have a question for you. Just thinking about the transition to synthetic methane. What are the timescales for that to reach the sort of scales that are necessary to decarbonize the sector?
It's a very good question. I think is it the World Shipping Council did some initial analysis and said that if shipping were to decarbonize through electrofuels, it would consume currently all the renewable electricity produced today. So that gives you an idea of the scale of the challenge. And albeit, I mean, we are seeing, every forecast of solar/wind capacity, particularly solar, that we see tends to be significantly wrong. We are seeing acceleration of that, but we have to see massive outbuilds of obviously renewable electricity capacity and electrolyzer capacity, and a fall in the costs of production of green hydrogen. That's not to say that I think that can happen. It's just as going back to my first point, decarbonisation needs to happen at sort of unprecedented speed. So we need to do everything. We need to do efficiency. We need to do, and I'm just thinking about shipping. This is a more general point, but we need to do everything we can.
Yeah, absolutely concur with that one. Yeah. Laurent, did you have a question?
Not a question, a reaction to the question of Air Liquide about the potential. You mentioned the potential transport. What we see, you believe it, you don't want to believe it, that's a choice, but when we see the potential in France, 300 terawatt-hour of biomethane, all sorts, all technologies, by 2050, let's say. That figure itself, I will dream to have 320 terawatt-hour of road mobility driven by gas whenever, whatever the schedule. That would be an enormous success, but I'm afraid we are very far from getting that figures. And so the question is that there will be biomethane in great numbers, in much greater number than the maritime shipping needs. You mentioned the numbers, the fleet of LNG. It's increasing fast. It's a big outlet, but I think for mobility, the bottleneck is not the biomethane. The bottleneck is the speed at which you transfer your transport assets into gas. That's the real bottleneck. The speed at which you can. We should revert our vision. Everything is complex. I'm not underestimating the challenges. There's challenges everywhere. But still, the first challenging regarding the figure is first to have gas mobility.
Did you want to pick that one up, Steve?
Sorry?
Did you want to pick up anything from what Laurent just said?
No, I think Laurent's right, and I think also if we're looking at road transportation, albeit there's a discussion. I mean, we do see, again, electrification playing an increasing role. So and people will say, well, no, it's not going to happen for HGVs, but I suspect it will happen faster than we think. So it's you just look at the general the trajectory.
And just to add, I second your point, Laurent, about there's not only challenges for fuel infrastructure to roll out, but it's also for the ships themselves to make the changes on board, and that then you have to think about, okay, well, how are the shipyards going to accommodate all of these changes? There's various knock-on challenges. That's not a negative statement, but it's a call to arms for we need all the stakeholders in the room to come together. That's why great organisations like the Maersk, McKinley Centre for Zero Carbon Shipping are doing just that, bringing all the stakeholders together. So, okay, thank you very much, Steve. I think because we've noted that our slot this afternoon is a full 3 hours, so we thought let's not sit for 3 hours. So we'll take a very short break and